Hi friends, welcome back to my YouTube channel. In this video, I'm going to take the lecture of 104. So I'm going to take MSc Biochemistry lectures from today on my channel, and I'm going to start each and every subject from the introduction, and then I'm going to complete all the 4 units of every subject. Here I'm going to start with 104 paper. So I'm going to take a first unit. Here I am going to give you the introduction of the first unit, the confusing terms. First we'll start from the confusing terms of this unit, and then we'll be going to see the introduction, what are the basic topics which is very useful in this paper, okay, in this first unit. So let's start with the terms called calorimetry and colorimetry. Here these terms are in pronunciations looks same, but they are different in terms of measurements of solution and a chemical reaction. If you talk about the calorimetry and colorimetry, so here in the biochemistry we are concerning with this term colorimetry, not with the calorimetry. So we need to know what this calorimetry is, right? So here first thing I'm going to define these two things. Okay, what is calorimetry? Calorimetry is nothing but here we measure the chemical reaction. Okay, and if we see here in colorimetry, here what we measures the concentration. We measure the concentration of a substance in a solution. That too, what type of solution? We are using a colored solution. Okay, colored solution. So this is how we measure. Here we are measuring chemical reaction. Here we are measuring the concentration of substance in a colored solution. Now if we see the principle, on which principle it works? Calorimetry works on the principle called enthalpy, heat capacity. Okay, while if we talk about the principle of colorimetry, here it works on the principle called Beers-Lambert's law. I'm going to discuss this Beers-Lambert's law in the colorimetry long answer. Okay, so it works on the principle called Beers-Lambert's law, and it works on the principle of heat enthalpy capacity. Who invented this colorimetry? Calorimetry invented by Antoine Lavoisier. And colorimetry invented by Jules Dobzhansky in 1854, while this was invented in 1783. Now you want to see the instruments, how they look. So this instrument looks like this. Here I'm going to draw. You can see this is the lid here which covers this vessel. This is the outer vessel, and we'll be having an inner vessel too. This is the inner vessel having the chemical reaction in it. Whatever chemical reaction we are measuring, the chemical reaction. And this is the stirrer by which we can mix the chemical reaction. And here we are having a thermometer. Okay, you can see this is the thermometer which reads the which takes the temperature of the reaction, and this is air space. Okay, and if we talk about calorimetry, might be the student who have completed their BSc in biochemistry, they know that they have studied the bomb calorimetry, right? They have studied the bomb calorimetry. What they have done in the bomb calorimetry, like they have saw at last sometimes the reaction has to hold the chemicals even in the large even in the large pressure. Even in the large pressure, they have to withstand with the reaction, because they need to measure what the chemical reaction is going on. For that they need to withstand with the large pressure as well. So this is how the calorimetry looks. But if we comes towards the colorimetry, here you can see it is a very simple electronic device. You'll be having an electronic device. Here you will be having a reading. You will be seeing the read output whatever we are getting, and here we'll be having some hole in which we'll keep the cuvettes. Okay, cuvettes. How we'll keep the cuvettes? We'll clean the outer layers with the tissue paper and then we'll insert it in it, so that we should not get interfere, or we should get the clear reading. Because of the substance comes on the what you call walls of the cuvette, it can interfere with the particles and light can not be passed properly. That's why we'll clean the cuvette from outside and then we'll insert it in it, and then we'll be taking a reading. Okay, we'll be keeping blanks, we'll be keeping standards as well in the calorimetry. Okay, so this is how we are going to take for the calorimetry. So colorimetry is different and calorimetry is different. So calorimetry procedure you know, now colorimetry is you know. So we'll be going to study this Beer-Lambert's law in the long answer of colorimetry. So we are concerning in this paper with the colorimetry, not with the calorimetry. Okay. Now we are going to see the differences of absorbance and OD. Here some people are getting confusing about the terms of absorbance and OD. Are they same? Are they same? Absorbance and OD? This is my question to you. OD is nothing but the optical density. Okay, optical density. So here we'll be going to discuss that. If we talk about the absorbance, here you know what is meant by absorbance. Absorbance is nothing but whatever the light is coming to the sample. Okay, suppose incident light has been incident on the sample. Okay, this is our sample. Whatever we have here, this is the sample and the light incident on the sample. Here some particle absorb the light. Okay, here we'll be indicating this term, this as a absorbance. So let me change the pen here. See, I'm indicating with the blue. Okay, sample is there, but indicating with the blue means here something is absorbing. The light is getting absorbed. Okay, absorbed. Here some light is getting absorbed and we are getting some transmitted light, that is I. Okay, some transmitted light, that is I. So incident light is falling down and then transmitted light is releasing. Some light is getting absorbed, that is measured by the absorbance. Okay, that is measured by the absorbance. If we talk about the optical density, here what we consider, will be considering the total, that is absorbance. Here we'll be considering the total, that is absorption, and also scattering of light. Okay, we'll be considering the scattering of light. Here in the other term we can also say that in other term we'll also can say that other terms, I can write that other terms, we can also say that transmitted light plus scattering light will comes in a optical density. So here how happens, here you know, this is the incident light falling on the sample, and whatever the sample we have will be get the some sample get absorbed and some get scattered. So this scattering light plus some absorbing light, this is the transmitted light. So this whole considered under the optical density called OD. And if we talk in the net this absorbance, here we will be considering the net absorption of light. We'll be considering the net absorption of light. I'm sorry. Okay, whatever light passed through the solution, that light we are considering here. Whatever the light is passing through the solution and some absorbed light, that we are considering in the absorbance, while in the OD we are considering the scattering light also. Okay, so here we can say that example for the OD is bacterial culture. If we take the bacterial culture, it has many substances, right? It has many molecules and culturing things and many bacteria as well. So what happens here, a lot of light gets scattered, so there will be a OD more compared to absorbance. And if we talk about here absorbance, here we can see clear or transparent or non-granular, or you can say non-turbid solutions will not get scattered. No scattering will be seen. So at this term, when clear and transparent, non-granular, non-turbid solution, no scattering will be there. So at this term, absorbance will be same as OD. So at this point, absorbance will be same as OD. Hence we can say that OD and absorbance are same. Hence we can say that OD and absorbance are same and interchangeable words. Okay, so this is about the absorbance and OD. Hope you got that difference. Now we'll be going to see two terms, that is spectroscopy and spectrometry. What do you mean by spectroscopy and what do you mean by spectrometry? Here, by the metry we can understand we are measuring something. By scopy we can understand we are observing something, right? Observation, here we are doing the measurement. And if we see here, observation means what we are observing. We are seeing the interaction. We are seeing the interaction between matter. We are seeing the interaction between matter and light, right? Here we are measuring, that is we are measuring the intensity of light on a particle, right? So that's what we are doing in spectroscopy and spectrometry, based on the measurement through electronic. Here we are seeing the measurements of intensity of light on a particle through electronic device. And what we are doing, we are taking those measurements and plotting a graph against OD and wavelength in nanometer, and this will be in this. So we are doing this, that's called as spectrometry. Thanks for watching. If you are new on my channel, please subscribe my channel and hit the bell icon so that you can receive more notifications like this.